So let's look at a few examples. So we've got a data set here, and I'm going to type everything in the Excel, and I'm going to use salt. So I've typed everything into Excel. So labels in that first entry of the first column and second column. Let's see, it looks like I've got a typo there. There we go. So I'm going to save this. Remember, you gotta save it as a CSV file. And then I'm going to go to Salt, and I'm going to go to Dataset, and I want to import and upload. I'm going to go where I saved it, my documents, and there it is. It's a CSV file. Open. And I'm going to select all because I need the X's and the Y's. You got to have both sets of data. And let's go back. I have 11 rows, and I have 11 rows here, so I'm good. So let's start by finding the regression. So I'm going to go to regression. This is my X. Y is in my Y's. So there's my scatter plot. Let me put regression line on top of it. So this is nice because it's giving a scatter plot. Now notice with that scatter plot, does this actually look like it's linear? I would say that it probably looks more quadratic, but let's look at all of our information down here. So we've got the formula. So, and they're using x for times. So this is really x times 0.5. 0.5 is our slope. And then that 3.0009 is our y-intercept. So I'm going to pull out my notes here so I can write on this and see both of these pages. So let me see if I can adjust. So our scatter plot actually looks quadratic. Nature. But now we've got this linear correlation coefficient, and that value is 0.81. And since that value is bigger than 0.8, we would say there is a strong relationship between these. And because they're strong, we can write this equation of a line. So this is 0.5x plus 3.0009. And usually with these lines, you're going to see this written this way with y with that little caret key over it. And we call that y hat, which means that we can use this line to find sample information. If we know other x values, we could plug it in and we could get a predicted y value. And that's the whole point of regression, is to be able to predict values. So how would we go about making a prediction, and when should we? Well, we only want to use the regression equation if the graph of the regression line on the scatter plot shows that we have a linear function, and this is going to fit pretty well. We also want that correlation coefficient to show that there's a decent relationship. So it doesn't have to be really strong. It doesn't have to be like 0.9. I would say even with moderate, we could get a reasonable output for a predicted value for a certain x value we're plugging in. If the regression equation does not appear to be useful for predictions, then it's best to use the predicted value of the variable as its point estimate, which means we're going to use that sample mean if it's not a good value. Another thing we need to talk about, well, before I do that, so we've got this. We said this is quadratic in nature, but we have a strong correlation. We could probably use this as an example to find a predicted value. So let's say, what if we want to find y hat when x is equal to 4? So all we would want to do is plug 4 into that. So y hat's going to be equal to 0.5 times 4 plus 3.0009. I'm going to do that in my calculator off to the side. And I got 5.0009. So that would be my predicted value. Now, is it going to be really accurate in this case? Probably not, because we're missing the fact that this is quadratic in nature. So you have to be careful when you make predictions. So the next thing we can talk about is a residual. The residual is the observed y value minus the predicted y value. So let's look at an example here. We've got this correlation and we've got this data set. We plugged in the value of 4. So the actual value when we plugged in 4 should have been 3.10. And the predicted was 5.0009. So the residual would be the observed, which is from your data set, minus the predicted. So 3.1 minus 5.0009, negative 1.9009. So there's our residual for that. In a scatter plot, an outlier is a point lying far away from other data points. It's possible that if one of these may be an influential point, which is going to really affect that graph and regression line. So let's do one more example. Let's take this data and let's plug it in and find that predicted value. So I've taken that data set, I have plugged it into Excel, saved it, and uploaded it. So I've got my X and Y. I'm asking, does the CPI predict the pizza cost? So here's my data points. You can see this is going to fit reasonably well with a linear function. So there is my formula that's associated with this. So I'm going to write this down. And notice my correlation coefficient. So my correlation here is 0.9852. That's really good. This is a really strong correlation. So yes, we would say that CPI is a good predictor of that. So my y hat value would be 0.0101 times my CPI, which I'll call X, minus 0.161. And I want to predict um, when it's 182.5. So I'm going to plug that in for this value. So when I type that value in my calculator, I get 1.68. And because we're talking about money, we want to round that to 2 decimal places.